Let's talk about dilutions of solutions. Yay. Okay, so welcome back again. Let's talk about diluting solutions. Um, Give me 1 second. I'm going to stop this for a second. All right, let's make sure I don't mess this up. But dilution of solutions. Okay, so concentration. We talked about concentration as molarity. So it means the number of moles per volume, or in this case, we're going to look at fish as an example. Okay, so we have 1 fish to 1 liter or 1,000 milliliters. If you take that and you add, so we have one molar, but if you take another concentration, you add a second fish, you still have 1 liter, but now you have 2 fish or 2 fishers. Okay, you take this and you add 4 fish, now you have 4 fishers. Okay, so but if I make it larger and I have a lot of fish in there, I have to count all my fish, and now I have a 4 fisher solution also. This one is the same as this one, it's just in a different size, okay? Because of the milliliters and the liters, okay? So let's see what else is next. So here's the same thing in moles. See, number of moles to the volume, 2 moles, 2 molar. 4 moles to a liter, 4 molar. 20 moles, same thing, 4 molar, okay? So, and then you can have a lot in 250 milliliters, you have 8 moles, you're going to have a 32 molar solution because it's very, very, very concentrated, okay? This one has more moles than this one, but they have the same amount of water, same amount of liquid. So you can kind of see the concentration. So this is what we're about dilution. So concentration is a measure of solute to solvent ratio. And it's either going to be concentrated or diluted. Concentrated means lots of solute. Diluted means not so much solute. Or it's watery. Kind of like your sweet tea or your watered down tea. Think of it like this. You have a soda. When you first put it in ice, it seems like it's really good, and then you let it sit for about an hour and all the ice melts. Now you have a very watered down solution. It's not very concentrated. So you add water to dilute it, you boil water off to get it concentrated. All right. So when we want a diluted solution, I want you to write this in your journal, this formula. M1 V1 equals M2 V2. Okay? So again, moles of solute remain, and the moles of solute remain the same. Okay, so we're going to kind of look at what this means. Okay, so let's take a look at a problem. Okay, so for instance, this is a problem that you would possibly see on a test or in the lab. It says what volume of 15.8 molar solution of HNO3 is required to make 250 milliliters of a 6 molar solution. The moles aren't going to change. We're still going to have the same amount of solute in there. We just want to know, is it going to be diluted or more concentrated? So what you would do is circle what's given. Okay. And then you would start labeling and underline what you're looking for. What volume? So we're looking for a volume. This is a molarity. This is a volume. And this is a molarity. Big M milliliters. In a dilution problem, you can have milliliters, but it has to equal milliliters. If you have liters and milliliters, you have to convert. If you have liters and liters, you can do this, but so it can either be milliliters equals milliliters, or it can be liters equal liters. Okay, so what you do is you take your M1 and you try to figure out which one's which. Well, remember I said of A? Well, this is a V1 or a V2, so I'm going to go ahead and, since it's already down here, V2, M2, so we're looking V1, M1. So you would write down what you have. So you would have 15.8 times your volume 1, which would be your X value, and then you have your other two values, your M and your V. You would multiply these two and divide by 15. Okay, so this is what you would have, 95 milliliters. And so we went from 95 milliliters to 250 milliliters. So your molar solution went from 15 to 6. It should decrease as well. Or, I mean, it should actually increase. They're inversely proportional. Okay, so let's go on to the next one. Okay, what volume of an 8 molar solution of KNO3 is required to make a 5-liter solution of a 2.0 molar solution? So we got a very concentrated solution going to a weaker solution. So this number, we're going to say we have this right here. That's an M. We're looking for a V. And of course, of, so there's a 1 and a 1. Here's a 5, that's a V2. And this is an M2. You see I have liters here, so it doesn't really matter. But I'm going to have an 8. I'm going to have an X. I'm going to have a 2. And I'm going to have a 5. You plug in your values to your M1, V1, M2, V2. My M value is 8. I don't know what the X is. And my M value is a 2 times 5. So I got 10 equals 8x. Divide by 8. And you end up with 12.5 liters. Okay? If I'm not mistaken. No, I think that's wrong. Something's wrong here. I think I put the wrong numbers in. Give me 1 second. All right, my decimal was just in the wrong place. So it's 1.25 liters. Okay? And that looks like that would look correct because it is watered down. So even if you make a mistake, just make sure you know what you're looking for. Okay, so let's take one that looks a little differently. It says if I dilute 250 milliliters of a 0.50 molarity of lithium acetate solution to a volume of 750 milliliters, what will the new concentration of the solution be? So this is my V1, my M1, my V2, and I'm looking for M2. So it's going to look a little different than the last one. My M1 was a 0.50. My V1 is 250. And then my M2, I don't know what that is, but my V2 I know is 750. Okay, you plug in your values. You put in 0.5 times 250 equals 750, X 750, okay? Multiply these two and divide by this one. So what you end up with is you should end up with 0.167 molarity. And it should be weaker because it says it's diluted. And we started out with a 0.5, we ended up with a 0.167. Okay, so come to class with these notes. Make sure you have all of the examples. If you don't do this, you won't do the lab, and we are going to make Kool-Aid.